Hello, guys. So this is our eighth lecture, okay, and we're gonna today continue our discussion about Karnaugh map or K maps. And today we're gonna explore the Karnaugh map for four variables. If your Boolean function is a function of w, x, y, z, or a, b, c, d, any four Boolean variables, how we use K maps in order to simplify it, okay? So as you see here, if you have four variables, you have 16 different combinations starting from 0, 0, 0, 0 until you reach 1, 1, 1, 1. If this is M0, this will be M1, then you continue until you reach M15. From 0 to 15, this will be 16 variables or combinations. Okay? Good. Now, since you have 16 combinations, you have 16 min term. Then we need a map that have 16 cells, and each cell is representing a min term or minimum term. Okay, so here is the shape of such K map. Okay, you have here 16 cells divided into a 4 by 4 matrix or array. Okay, so each two variables will take, for example, like what we did with the three variable, x was representing the rows, yz was representing the columns. Here you have 4. So W, you can choose this WX representing the rows and YZ representing the column, or you can do the opposite. That's fine. Okay. And here is the location for each minimum term. For example, minimum term 0 is here, minimum term 11 is here, and so on. But how we construct, if we don't know this, if it's not given, okay, how we know that such a cell representing such a minimum term? Again, we go back to the procedures that we learned starting by Karnaugh map for 3. Here is Karnaugh map for 4. So what we do, we say that, for example, the rows representing the WX and YZ representing the columns. So the first row, for example, is 0, 0. So when you have a min term or a row term in your function that has w bar x bar, then it is the first row. Then 0, 1, and remember we want 1 bit change, not 2 bit change. So the most significant bit here is a 0, has no change, but then we change it only the bit corresponding to x. If we go to 1, 0, then we will have 2 bits of a change. So we will not go to 1, 0, we will go to 1, 1 directly. Because if you go to 1, 1, then the least significant bit is 1, doesn't change, and only the most significant bit has a change. Then you go to 1, 0. Because from 1, 1 to 1, 0, you have only, again, single bit of a change. Okay, and we explained last video, why we need just one change, not 2 changes. Because if you have 2 changes, you cannot combine the adjacent ones into a group, because you will not find a common factor. Now let's do the columns. If the first column is 0, 0, I mean y bar, z bar. The second column is 0, 1, which is y bar, z, and you have 1 bit of a change. Then the third column should be 1, 1. Then 1, 0. Again, here you notice that we have only 1 bit of a change between each two adjacent columns. Again, like what we explained in the starting from the Karnaugh map for 3 variables, we said that the edges are connected, or the K map is folded. But it was only from one way, from the edges here in the 3 variable Karnaugh map. Here with 4 variables, the edges are connected. So this edge is connected to that edge. And the top and bottom are also connected. So the sides are connected. Then the top and the bottom are also connected. I mean, if you have, for example, here 1, 1, I mean, f equal to m1 plus m9, then you can combine this guy with this guy in a group. Okay. Also, I mean, if for example, f equal to m4 plus m6, then you can combine this guy with this guy in a group because it's foldable like this. Foldable like this and also foldable like this. Okay. Good. So let's take our first example here. So f equal to summation of main terms 0, 8, 2, 8, and 10. 0, 2, 8, and 10. And based on the, the observation that it's folded from the sides and so from the top and bottom, then look, this guy and this guy can be considered adjacent. This guy and this guy. Okay. This guy and this guy can also be considered adjacent. Good. This is from the sides. But remember, the top and the bottom are also connected. So this guy, let's do it with another color. This guy and this guy is connected also. They are adjacent. So let's do it with, check, check. And this guy and this guy are also connected. Let's do it with, double crosses like this. Okay. So basically, they are all of them are connected now. I mean, you can combine this one. Let's do it with another color. Let's have red. I mean, you can combine this one with this one, with this one, with this one in a group. Okay. So remember, again, the two adjacent corners are, the two top corners are connected. The bottom two corners are connected. But also the top corner, top left, top right corner, and bottom right corner are also connected. Top left corner and bottom left corner are also connected. So they can form a group. Okay. So F here, if we go back to our normal color, let's see how we can combine these and remove some literals and and only consider the literals that are not, or the Boolean values that are not changing. Okay, so look here, this is W, so these two guys are W bar. This is Y, so these two variables are Y bar. This is Z bar, this column I mean, and this final right column is Z bar. Top row is X bar, bottom row is X bar. Okay. So in these 4 ones which which represent one group, you have in the first column X bar, you have in the last in the first row X bar, in the last row X bar. So X bar doesn't change. Okay, so you can consider it in our final expression. The top row or the top 2 ones are W bar, the bottom 2 ones are W, so W is changing, so we'll not consider W. The first column here is Y bar, the last column here is Y, so we will not consider Y because it's changing. But the first column is Z bar, the last column is Z bar, so it doesn't change, so we can consider Z bar. And remember again and again. This is just analytical simplification, okay? But it's done in a very systematic way, without even considering any trick like what we used to do in our previous weeks. So let's do that. So basically, F equal to 0, 2, 8, 10. 0 is M0, which is, so F equal to W bar. M0 is W bar, X bar, Y bar, Z bar. M2 is 0010, which is W bar, X bar, Y, Z bar. M8 is 1000, which is W, X bar, Y bar, Z bar. And M10 is 1010. So 1 W, 0 X bar, 1 Y, 0 Z bar. So let's look now for the common factor. The common factor is W bar is changing, X bar is a common factor, W, Y is changing because here it's the Y bar, here it's Y. Z bar is also a common factor because it's Z bar in all the terms. Then, if we take X bar, Z bar as a common factor, then we will end up with W bar, Y bar from the first term, then W bar, Y from the second term, then W, Y bar from the third term, then WY from the fourth term. Okay. And again, if you remember, guys, from our last lecture, this is equal to 1. And we proved that. So this is equal to X bar Z bar dot 1, which is X bar Z bar. Okay. Why it's equal to 1? Because basically we considered all the situation for Y and Z. If we consider this as a function, if dash, for example, equal to, or not if dash, not to confuse you guys with the inverter. If we consider any function like f2 equal to W bar Y bar plus W bar Y plus WY bar plus WY, for any value of Y or W, this f2 will be 1. If we check, for example, W equal to 0 or Y equal to 0. If Y equal to 0, okay, this will give us W bar. Y equal to 0, this will be 0. This will give us W. This will give us 0. So W bar plus W is just 1. Okay, and you can, try with any other value for Y and Z, for Y and W, you will end up with 1. So this is always equal to 1. That's why the final shape of F can be simplified to X bar Z bar, just like what we did with the Karnaugh map. And here is the answer why we should consider in a group, in the ones group that we choose from our Karnaugh map, a power of 2 numbers. I mean, power of 2, we can take a group of 2 ones, or 4 ones, or 8 ones, or 16 ones, but we can take a group with 3 ones or 6 ones, because this is not a power of 2 number. Okay, and the reason is that if you take a power of 2 number for the number of ones, then basically you will end up with something like this. If you take a power of 2, a group of, and this group has a power of 2 number of ones, like 8 or 16 or 4 in our case here. Okay. If you take 8 ones, as we will see in our next examples, then you will have 8 combinations, something like this, but with 3 variables, it will be 8 combinations. And again, this is a function equal to 1. Okay. If you take a group that has 6 ones or 3 ones, you will not have a function or a combination like this that equal to 1. You will not have this. That's why we cannot make a group of 3 ones. Okay, so let's continue with other examples. Here, f equal to summation of many, min term, so 0. So 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. Okay. And look at the numbering. Before we continue in that, look at the numbering of the main term. So here is M0, 1, 2, 3. I want you to to grasp such way of writing down which cell corresponded to which we explained at the beginning of that video. But this is another way to visualize it. So go in that pattern of numbering. Instead of putting 0, 0, 0, 1, and search each time which minimum term this is representing, you can do in that way. So 0, 1, 2, 3, 4, 5, 6, 7. Then 8, 9, 10, 11, 12, 13, 14, 15. And why such way? Because 1, 1 here is before 1, 0. So we go to 1, 0 first, then we go back to 1, 1. So that's why 0, 1, then we go to 2, then we go back to 3. Same is here, because 1, 1 in the rows is before 1, 0. So when we reach it 7 here, then 8 was here. 8, 9, 10, 11. Then we go back to 12 here. Okay. Now let's go back to our question of this simplification. Again, the same rule applies. Start by the isolated ones. Okay. So let's see. So here looks like these 3 ones are isolated. Okay. One may say, okay, you know that this edge and this edge are connected, so let's do this group. These 3 ones with these 3 ones. Then I would say, hey, that's incorrect. That's 100%, 1000% incorrect. You can't do that again because the group should have a power of 2 number of ones. This group here that you may choose has 6 ones. 6 is not a power of 2 of ones. We should choose a group that has 2 ones, 4 ones, 8 ones, 16 ones. And of course, in our case, it's a maximum 16. For 5 variables, you will have 16 and 32. More than 16. Okay. And of course, the more ones you have in a group, the better, because this will make more simplification. And again, the number of variables that will be that you will get rid of in a group is equal to log 2 of the number of ones in that group. If you take a group that has 2 ones, then you will get rid of 1 variable, because log 2 of 2 is 1. If you have a group with 4 ones, then you will get rid of 2 variables, because log 2 of 4 is equal to 2. So what we're gonna do here, we can't do such, but you can do something similar. You can take this guy, these 2 guys with these 2 guys. So if, let's write this all the way. So F equal to, so the first group here will give us, remember, this is Y bar. This is W, this is W bar. This is X, so this is X bar, this is X bar. These 2 are Z, so this is Z bar, this is Z bar. So the first group here, the first row is X bar, but the second row is X, so X is changing, we will not consider it. The first row is W bar, the second row is also W bar, so W bar is not changing, so we'll take it, we'll consider it. The first column here is W bar, the last column here is the first column here is Y bar, the last column here is Y. So Y is changing, we'll not consider it. But the first column is Z bar, the last column is also Z bar, so we'll consider Z bar. So the first group gave us the W bar, Z bar. How about this guy? So take this guy with this guy and these 2 guys as well. One may say, why we didn't take these together? Yes, but remember, these 2 cells are also adjacent to these cells. Okay, so the more ones you have in a group, the better. So let's check what we're gonna read of, what we're gonna take, and what we're gonna leave. So this row and this row is x. So x is not changing. So x. This row is W bar. This row is W. W is changing. We will consider W. This column is Y. This column is Y bar. Y is changing? We will consider Y. But this column is Z bar. And this column is also Z bar. So we'll consider Z bar. Because it's not changing. Good. Now we have, these 4 ones and this one, these 5 ones. This one, this guy, this guy, this guy, and this guy. Okay, so let's have another color. Red, for example. We will notice something here, okay, that you can consider one group that has 8 ones, and at the same time, this group will take all the 5 ones left, which is this group here. This group has 8 ones. So log 2 of 8 is 3. So we'll get rid of 3 variables out of this group, and we'll end up with only one Boolean variable. So let's see. This column is Z bar, but this column is Z, so Z is changing. We will not consider it. Okay. These 2 rows is W. These 2 rows is W bar. W is changing. We will not consider it. This row and this row, the first row and the last row is X bar, but the second 2 rows is X. So X is changing. We will consider. But these 2 columns has Y bar. So Y is not changing. So the last group here will give us Y bar. Of course, there is a solution, but I'm doing the solution with you, step by step to show you how to do such stuff. Okay, and the book is really nice here because he always, makes analytical simplification, to prove you or to make it more clear for you that this is just analytical simplification, but done visually. Okay, in a visual way. So let's take now our last example in that video. Okay, in which it's also similar to our last example with 3 variables schema. Okay, now not all the terms are min-term. Only one of them is a min-term, this one. But the others are not. So we learned 2 ways to do that last time. Okay, the first one is to convert each non-min term to into min-term terms, because this will be converted into 2 mid-term because there are 1 missing variable. If you have 2 missing variables, you will have 4 min-terms and so on. Okay, and another one which is just by locating all the cells that represent each term. Okay, so I will do the second way because it's easier and short, and I will do it also in another way. So last time, okay, what we did, for example, let's redo our last time method with A bar, C bar, A bar, B bar, C bar. Okay, so where are the columns or the rows that represent A bar? So A bar, this column or this row and this row. Where are the columns or the rows that represent B bar, C bar, or I'm sorry, B bar first? B bar is the first row and the last row. Where are the columns or the rows that represent C bar? C bar is represented by the first 2 columns, so this column and that column. So now, where are the cells that represent the 3 literals? A bar, B bar, C bar. Basically, they are the cells that has 3 lines. Okay, because we have 3 literals. So basically here, these 2 ones, this one and this one here, this cell and this cell has 3 lines, 2 vertical and 2 horizontal and 1 vertical. So these are the others that you will have only 2 or 1. So this, for example, have 1 line. This has 2. This has 2. This has 1. This has 1. This has 2. Okay, so basically A bar, B bar, C bar will be represented by the first two cells here. Although this will make your drawing, you know, messy. So let's do this another way. So let's have another color. So B bar, C, D bar. Okay, B bar, C, D bar. So this is basically 0, 1, 0. This is CD, and this is B, and we need A, right? So both A once 0 and once 1. So 1, so 0, 0, 1, 0, and 1, 0, 1, 0. These are basically the main term, right? So 0, 0, and 1, 0. Where is 0, 0? Here is the 0, 0. Where is 1, 0? 1, 0 is that one. So here is the intersection. So both here 1. Then 1, 0, 1, 0. Here is the 1, 0. And here is again the 1, 0. So the intersection here will be in that cell. So we did this also. Another color. Now, where is the cells or the cell that representing A bar, B, C, D bar? So this is basically 0, 1, 1, 0. So there is 0, 1. And then 1, 0 is also here. So the intersection is that cell. Finally, with another color, let's do green. Oh, no, we did green, blue. A, B bar, C bar. So this is basically A is 1, B bar is 0, then C bar is 0, then D. So this is A, B, C. So this term doesn't care about D, right? So you can just put D once 0 and once 1. Okay. So 1, 0, 0, 0, 1, 0, and 0, 0. So the intersection is that cell. Then 1, 0 again, same row, 0, 1 is now the second column. So this one. So these are the ones that you see, guys, here that represent our function. And both zeros, I usually forgot to put these zeros, but we should put them. Okay. Now let's make the grouping. So let's go back to blue now, or yeah, that color here. Let's do the grouping. Let's start by the most isolated ones, which is that guy here. So, but remember, this is on the corner, right? And we said that this corner and this corner is connected. This corner and this corner is connected. This corner and this corner is connected. And that corner and that, is connected as well. So basically, this is a group. The four corners will form a group. So what this group will give us, let's see which is changing, which is fixed. So these four corners are the first and last row, first and last column. First column and last column has D bar as no change. So if equal to D bar, because it's not changing. First column and last column has C bar and C. So C is changing, we not consider it. First row and last row has A bar and A. So A is changing, we not consider it. But it has B bar and B bar. So B bar is fixed. So we consider B bar. Plus, what kind of ones we still have? So we still have, let's do with this pink. We still have this one here, and this one here, and this one. Okay. So let's start by that guy because it looks like it's isolated as well. Okay. So basically, we have no option. We have no option except these two ones here as a group. These two ones has C. C is not changing. has D bar, not changing. This row and is B bar, this row is B, so B is changing. But this row is A bar, this row is also A bar, so A bar is not changing. And we still have 2 ones left. So let's go with another color, the cyan, for example. So one may say, let's take them together, right? No problem. But your your simplification will I mean your minimization will not be the optimum. You will have extra gate. So basically the best thing here, remember that these are two connected and these two are connected, and then this edge and this edge is also connected. So basically perform such group here. 2 from the bottom and 2 from the top. First row has A bar, last row has A. So A is changing, we not consider it. First column has D bar, second column has D. D is changing, we not consider it, but both has C bar and both has B bar. Okay. So we could simplify, this long 4 terms into only 3 terms, okay, with even less number of literals in each term. Okay, guys, so stay tuned for next videos. We're gonna continue our simplification methods. See you.